Well, thank you all for joining us here today, and you guys as well. Mike didn't mention, but of course, if you have any questions that you want to submit for their consideration, you can use the TechCrunch Disrupt app and find our session here, how to build a space economy, and submit your question, and I will see it. So why don't we start with a quick intro? Why don't you guys tell me a little about what you do, what your company does? Why don't you take it away, Tess?
Good afternoon, I'm Tess, and thank you, Devin and TechCrunch, for having me back. I invest in frontier tech at Bessemer Venture Partners, specifically space, drones, and autonomous vehicles. I spend my time in that first industry, space, due to my background as an aerospace engineer. I have degrees in the field. I used to be a mission manager at SpaceX, where I worked on integrating satellites with the Falcon 9 rocket. At Bessemer, I'm involved in our investments in Rocket Lab, a tiny rocket, and am the director of Spire Global, the largest general-purpose CubeSat constellation. I'm passionate and I spend time in this field because I imagine a world where one travels to space with the frequency that we currently travel in an aircraft, and I hope to make the trip myself someday soon.
I plan to as well.
Great.
Sarah, can you tell us a little?
Hi, I'm Sara Spangelo, CEO and co-founder of Swarm Technologies. We've developed the world's smallest two-way communication satellites. I actually have one here. This is not my handbag. So our satellites are about the size of a grilled cheese sandwich, as Twitter likes to say. So this is actually one of our satellites. We have 9 like this up in space today, and we're planning to deploy a constellation of 150 of these to provide for global continuous coverage, essentially solving for connectivity every point on Earth at all times, largely focusing on IoT, so think agriculture, logistics, energy, US government, those types of applications. And we're just really excited. We're going to be deploying our constellation in the next year and starting to operate commercially this year in the US.
Great. And Adrian?
Hi, my name is Adrian. I'm the CEO of OneWeb. I've been there for a year. And we're focused on providing connectivity, broadband everywhere on the Earth. We think there's a big need for it, particularly focused on doing that in schools. And also think that the way our business works, there's a clear subsidy of the business we do in the developed world for higher margin businesses, airplanes and maritime, that subsidizes connectivity in the developing world. So the mission of the company is to do our part in terms of connecting everybody.
So all of you have been in this business for a while, and several of you have put satellites into space. Can you tell me, do you think that space is really open for business now, or is it still kind of a private club?
Well, I love the space is open for business headline, and wrote an article on your Medium about the effect of Moore's law miniaturizing components. And before, the only way to get a sensor into space was this massive school bus-sized satellite that would take decades and hundreds of millions of dollars to put into space. And with Moore's law, you can now take a cell phone or Sarah's B, which I think you call your satellites, into a low Earth orbit. And it's really lowered the barrier and democratized access for space. And I do think it's open for business. It's easier to put assets into space. Easier,
but still costs, tens of millions of dollars. Like, what do you, no? You don't think so?
I would defer to Sarah, but I don't, the cost of that is definitely in the 6 figures, 5-6 figures.
Can't comment on that.
You can go ahead and give us an exact number.
I think, we've seen this evolution over the past even 10 years. So when I was doing my PhD at Michigan, we were launching the first CubeSats, and we were trying to prove that they could do real science. And that was actually a huge question in 2010. And through NSF, National Science Foundation funding, we were able to show that's true. And then I think there was a question of, can satellites do useful imaging? And Planet Labs and Skybox have really demonstrated that that's true. And I think we're on this next peak of, can they solve for communications? And I would say that companies like us and OneWeb and several of the others are entering this ecosystem and have real technology that we've demonstrated works in space. And we've raised capital to deploy constellations and are executing. So I would argue we're probably, at least from Swarm's perspective, a year out from fully deploying our entire constellation, but we're extremely close. And as Tess mentioned, the reduction in launch costs and access to space is enabling that in a tremendous way that I couldn't have even imagined 10 years ago.
Yeah.
So I think the space is open for business. I think that everything that Tess and Sarah have said is absolutely true. But what I'd add to that is not only true so far, but the trend is accelerating. We see launch costs continuing to go down. We think that there are different folks working on even disrupting the disruptors today with different technologies for doing that, whether it be 3D printing. And then we also have all the benefits of the miniaturization of components for the iPhone and for smartphones. And so satellites are, if they're 100% today, we think that they will be 6 to 7 times more powerful 3, 4, 5 years from now. And so if you think in a sort of a time horizon of 10 years, there's a big change going on. And you'll see that, I look at these things as, these satellites as flying base stations. Really there'll be huge portions of the Earth that'll be getting service that way.
So it has gotten a lot more democratized, and the costs have come down, but it's still very capital intensive to go from 0 to satellite in space. How has that capital ecosystem changed? Because over the years we've gone from you needing, $1 billion to $500 million to what we're looking at now, venture investment at pretty reasonable levels. But what are the trends there? Are we reaching a sort of like floor of how much venture capital is needed to get these satellites into space? Like how are these trends changing along with the lowered costs?
I do want to make a point that the industry is shifting, and instead of focusing on cost per kilogram to space, it's now time to space, with companies like Rocket Lab that are planning on launching at a weekly, if not twice a week cadence by next year. It's so important that rather than focusing on how much it'll cost you to get to space, to get your sensor into space next week, next month, and then to start generating your product and revenue. Regarding the question on capital and venture trends of space companies, it's definitely decreased. I'm so impressed with the Series A or seed stage companies that already have one or many satellites in orbit. So the rounds have stayed the same of dollar amount, but space companies have been able to do a lot more with the capital.
Yeah, I think totally agree with all of that. I think that the fact that with small satellites, a 1U or quarter U's, if you do the math on how much it costs to launch into space, you can do that for a few $100K. And if you raise a seed round of a few million, it's conceivable to get first satellites in space. With Swarm, we did it in 11 months. We had 4 satellites in space, and obviously we moved very quickly. But that's feasible. And then I also think that at the kind of Series A raise, so we raised 25 million, that's more than enough to deploy our entire constellation. We're at this sweet spot where kind of constellation launch cost meets VC Series A, which has never been possible before. You've had to raise billions before. So I think it's kind of, we're in the sweet spot where it makes sense and we can achieve this, and I think there will be others that come in and do something similar. And it's pretty exciting that we can do that with, with VC funding for a few $1 million, satellites in space.
So Adrian, if I could maybe adjust the question slightly for your purposes.
I wish I could be saying the same thing. But, so we've raised $3.4 billion and have 6 satellites in space.
Yeah.
If you all want to write a contribution, I'll be at the stage.
Yeah, we're gonna pass the hat around a little later to get that 7th. I know you're really looking for that 7th one to get out up here.
Listen, we look at this as we're going to be the biggest global ISP. We're going to have full coverage of the Earth, and we've already demonstrated our system of giving 355 megabits per second with latency of 32 milliseconds. So we're building something that has scale, and the nice thing is we have spectrum worldwide. And unfortunately, the costs haven't come down quickly enough. Thinking about what Tess was talking about in terms of launch, weekly or monthly, we signed a huge contract because we needed to program out 22 launches because it does us no good to put up 35 satellites, then wait 6 months, and then put up another 35. We need to get these things up as quickly as possible. But if I look forward, the technology is becoming more powerful. There's going to be over the next 2 years, 3 years, 10 years, launch costs are going to come down. There are going to be more options, and so that's all good. And the satellites are becoming much more powerful. And I feel like I'm the old economy guy up here on the stage, but we don't really see it for what we're doing. Maybe it would have cost 5 times more or been impossible to do 5 or 10 years ago. And so our ambitions are to do something that really is complementary or competitive with what telcos do worldwide.
So I guess I would sort of change the question a little bit for your purposes, Adrian. How are the legacy industries like telecoms, how are they being dragged kicking and streaming into the new space-based economy? And how can we get them to make investments on a smaller level as well?
So our point of view is different than other people's. We think, first of all, we're in the connectivity space, and so we have a premise which fiber always wins. Right? If you've got fiber, and I've laid a lot of fiber, you win, okay? The issue is that you can't lay fiber everywhere. And I've laid fiber through the Andes and in the Colombian jungle and in lots of parts of Mexico, and people don't focus on maintaining that fiber. There are fiber cuts constantly. So you gotta have people, teams of people. You can't really deploy fiber everywhere. You can't do it in large, in deserts, in the steppes of Russia, in the tundras of Canada, and through large parts of Africa. So we think that this is a very elegant solution to complement terrestrial. And terrestrial is getting more and more advanced. So you've got 5G coming on, but 5G is all higher spectrum, which is good at delivering a lot of bits at short distance. And so we want to play in tandem with them. There are other technological developments in microwave, point-to-multipoint, millimeter wave, in terms of distributing bandwidth. But really, we think that what we're doing with space and what others are doing really is a game changer in terms of being able to give connectivity everywhere that it doesn't make sense for terrestrials to do. So we want to do in cooperation. For instance, we could be useful for redundancy here, but I wouldn't see San Francisco being a market for us, right? As an example.
So if I could talk a little bit about, or if I could ask a little bit about the hardware side. Not every startup is going to be working just on the low-cost side of like, oh, we're going to work with orbital data. We can take data from Planet and do something cool with that. Like, you wanted to put together your own satellite from scratch. What does that look like? What does that process look like? What can an entrepreneur out here look forward to? And how do you think that has changed over the last few years?
Yeah, absolutely. So one of the biggest strengths of Swarm is that we are fully vertically integrated. So we actually build our satellites end-to-end completely in our lab, and we test them. We actually hit a milestone where we built and tested 14 satellites in a week, which is pretty phenomenal if you come from the space world, right? We have a pick-and-place machine where we actually build our single-board satellites. We have a clean room where my CTO, who's here in the audience, assembles the satellites, and other people on our team do. We have a vibe table in-house, and because we own that end-to-end process, we're able to control quality as well as move very, very quickly. So I would say don't shy away from hardware as long as you have a way to execute effectively and really efficiently and quickly. And I think that's actually one of the biggest strengths of Swarm and how we're able to deliver so many satellites so quickly at such a low price point.
So can you give us a general idea? I mean, I'm not asking you to disclose specific numbers, although I'd love to, if you don't mind. What does it cost to put together a satellite from scratch? Because sometimes you hear about a student who did it in their back, in their garage for $50, and then you hear about a real one that's up in the air and sending back data, and it costs however many $1 million or thousands of dollars. Like, what does that investment process look like? Do you look at the size first, the technology of the antennas that you need? Like, what actually goes into creating the satellite? And Adrian, I would like to go on to you after this because you have a more traditional satellite, larger and using more traditional parts, but that's an industry that's changing as well.
I think when you look at designing a satellite, actually the first thing you look at is the launch costs, because those often drive the cost of the constellation. So when we looked at launch costs, the smaller we can make the satellites in mass and volume, as you mentioned, both of those are constraints that are becoming active. We wanted to make the satellites as small as possible because we can launch 12 satellites because our satellites are a quarter U, where most people that are launching 3Us launch 1. So that's extremely powerful. So we started there, and from that point, we essentially came up with all of the design elements to be able to make the satellite stabilize, do the communications that they need to do, have GPS, have the redundancy, the software, the processing that they need. And I would say that, I'm not going to comment, but it's somewhere between a few $1,000s and $1 million, and that's really some of the secret sauce of our company as well. And I think just being extremely creative and clever with how to build that satellite using as many commercial off-the-shelf components as you can, doing testing to mitigate against a lot of the risks, doing a lot of things cleverly in software versus redundancy in hardware to try to reduce those costs.
Mm-hmm. And Adrian, we were talking backstage a little bit about how economies of scale haven't really applied to satellite manufacture in the past, but that's changing as there's a market now for creating 600, 700, 10,000 satellites. How is OneWeb experiencing that change in the manufacturing ecosystem?
So we've tried to become as vertically integrated as we can. So we have a joint venture with Airbus. It's called OneWeb Satellites, and that's where we have a factory in Cape Canaveral where we put these together. I think that one of the challenges we've had, and it's taken us a while to do this, is it's not just putting them together, but it's when you're dealing with your suppliers in terms of the different components that we need. It's not we don't want 1 or 5 or 10. No, we want 650, and we want to be able to produce these at a rate so that the rocket, the inventory on hand is there to put up into space. Frankly, I'm jealous of Sarah because I know her number's lower than the high part of that range, and ours actually, we've been pretty public. Our cost is about $1 million, and if we did more of the same satellite, it drastically goes down. So we're just, the OneWeb Satellites put out a photo on LinkedIn a couple days ago saying, 100 years ago it was Ford, doing assembly line production of cars, and OneWeb Satellites are doing that with satellites. We think that the partners that we have in the industry haven't been used to that volume, and so it's a whole ecosystem, and we want to get as vertically integrated as possible, and then that's only a portion of what we have to put up in our system. Where the other part is the ground stations and the SOC and the NOx and all of that. So it's very challenging, but what I tell you is that the economies of scale do work. It's just a matter of priming the pump and getting things going.
So I want to talk about regulations. We had a question from the audience about regulation as well, and I had it here as well. Where should founders start to avoid run-ins with federal agencies and be able to navigate the regulatory environment? Extremely complex, extremely time-consuming, red tape everywhere. Where do you start as a founder, and what do you add as an investor to to help the companies that are coming through Bessemer be able to navigate that space?
When Sarah was answering the question on what do you design for and launch vehicle being a very important piece, I think spectrum is the second most important piece, is applying to the FCC, so a regulatory entity, and one, figuring out which spectrum you want your satellite to operate in. And I think Swarm and OneWeb are on very different sides of the spectrum, pardon the pun. Mm-hmm. And that being a really long and tedious process that I have not gone through myself, so I will defer to Sarah and Adrian on the nuances and the tips and tricks on how they've been able to do it successfully. But it's absolutely something I dig into because it takes years at times, and it should be one of the first things a space founder does when they're designing their satellite to start filing for their spectrum allocation.
Yeah, so absolutely identifying what spectrum you're going to use is important, but it's also very important to establish a relationship with the federal agencies. So I often visit the FCC, sometimes monthly. I meet with the bureaus, I meet with the commissioners, I meet with the chairman last visit. and just really telling them about what we're doing and how it helps them solve. So the FCC is committed to solving for things like remote connectivity, ending the digital divide, and really just getting them on board with our mission, and then communicating to them where we're applying, how we're following the rules, how we want to move forward with our licensing plan. And I think that's been probably the most powerful thing to do to move that forward. But it's absolutely the most difficult part of starting a space company is the regulation side of things. And we've learned that obviously at this point, and I think even going backwards, if I'd known what I know now, I would have spent more time on that in the first few months that I started Swarm. And we've been able to navigate relatively quickly to get to a point to launch our commercial constellation in 3 years. But you look at most of the space companies, it typically takes 5 to 10 years to get their regulation stuff all figured out. So it's no joke. Get your lawyers queued up, know what spectrum you're going after, and then work with federal agencies early on.
I think spectrum is our number one asset. So, I mean, if you think about, we have a very high priority in KA and first priority use in KU worldwide through the ITU. In fact, so I've gone a lot to visited often with the FCC, but we're actually a UK company, so we've done that through our regulator is Ofcom in the United Kingdom, and then the worldwide regulator is the ITU. So spending a lot of time and having good lawyers is important because there are other people out there and they got sharp elbows, and it's no joke. If somebody's got, lots of people have access to spectrum and different priorities. If somebody's got an idea that what they ought to do is see who they can work with that already has access and scale and an ability to distribute. That would be my recommendation.
Part of the space ecosystem that is perhaps not adequately regulated right now is debris. That's something like everybody is concerned about. I've got a question right here from the audience about it, and I was going to ask about it anyway. How are you guys all? How are you addressing the problem of orbital debris? And how would you advise founders incorporate that concern into their companies from the start?
Yeah, definitely. So orbital debris is a major concern for us as well as should be for most space companies. And I've been highly aware of all of these issues, started my career at JPL, and there's a lot of modeling that goes on there. So these issues have come up for a while. So whenever we make any applications to the FCC to launch any of our satellites, we do this modeling, which is it's a NASA type of modeling called DAS that basically helps you calculate the probabilities of collisions and any risks. And so we run that for all of our satellites. The probability of collisions for our satellites, partially because they're so small and also because they're in good orbits that aren't overpopulated, is essentially less than the probability of getting struck by lightning. So it's actually, if you look at the data, it's very, very low. And we do take that data-driven approach. We also track all of our satellites at all times using 3 different methods. We use CSPOC, which is the government. We use Leo Labs, which is a startup in Menlo Park area that tracks satellites. And then we have onboard GPS. And if any sort of collision risk is estimated, we actually have a way to maneuver our satellites to change their drag profile, which changes their orbits, so that we can essentially make that risk of collision go to 0. So something we take super seriously in our company. We invest a lot of resources into that. And we hope that all other players in this space do as well, because obviously this is something that everybody needs to care about to minimize probabilities of any risks.
I think orbital debris is the number one issue we're facing. I mean, everybody's got their issue with making their business plan work, getting things up and working. The problem is a lot of the rules, whether it be insurance rules or the way fees are calculated by regulators in different countries, are based upon the old model of the big geo. And I'm dealing with that in my home country where I'm American, but in our home country as a company, where those rules were written in '97, and they're thought of, this big geo satellite. And so they really nobody's regulated that. And usually as a private company, you'd say regulation is anathema. I don't want regulation. The problem is everybody is going with their home country, and some countries are more stringent than others. And listen, if the example I use is if you have a collision up there, Our satellites are going 16,800 miles an hour. It's not like our cars bump into each other, we walk out of the car, exchange insurance cards. These things will absolutely spread debris everywhere, and you can't model where it's going. And it's sort of like shards of glass going on the sand, and you're asking people to keep on walking there. So you would be spoiling a shared natural resource. And so, basically when you say, there was this issue between the ESA satellite and the SpaceX one, and we're saying it's 1 out of 1,000. Listen, if you drive on a road with around a blind curve 1,000 times, you got 1 in 1,000 times, you got 10,000 times, you will die, okay? And people do get struck by lightning, so it will happen. And so what's going to happen is that the typical thing is companies say, no, we don't want to get regulated, because I don't want to be regulated. It goes sort of anathema to the whole notion of disruption and innovation. On the other hand, typically what happens is the regulator shows up after there was the big accident. And so I think people have to sort of, breathe in and see what is it you have to do, and the industry ought to lead that, because otherwise it's going to just be a mess, and then nobody will like the regulation. I think that you got to put up satellites that if they're not functioning, you got to take them down. And again, the rules are for GEO, so they've got these long timelines, and they're not really moving relative to other things, right? And so I think there's it's got to be a worldwide sort of ITU type of regulation.
Mm-hmm.
I actually do not think space debris is a big issue at the moment. The International Space Station has only had to have moved half a dozen times since its launch in '98 due to tiny pieces of debris to get out of the way. It will become an issue when and if these constellations deploy. You're projecting 600 plus, Starlink and Amazon's constellation.
So we'll be 2,000.
Helping my point, 2,000.
But at higher altitudes.
That's part of the reason we're at 1,200, because there's less stuff up there.
But they got to come down. But you have propulsion, yeah.
But space is big. You're launching in 1,200. LEO is from 400 to 1,600. I agree that it's an international issue that everyone will have to prioritize, and I'm delighted that startup companies and the people that are launching these constellations are really conscious that this is an issue that they have to mitigate, whether it's having propulsion on board, active or passive. You can get out of the way of other things, or companies like Leo Labs that are monitoring and tracking down to 2 centimeters. But simple things like when your satellite's dead, like GEO, X amount of time afterwards, you have to deorbit, and usually you burn up upon re-entry as you're entering Earth's atmosphere. So I'm not as scared about space debris as some people claim. It's the inhibiting or a big restrictor for all of these satellites to be deployed and for LEO to be democratized. There's pretty straightforward steps that these companies can take, but it does come down to the FCC, which we were complaining about earlier, but the importance of regulatory entities that are in control and make sure that we're operating space safely.
My point, Tess, is that it's not up to the FCC. The problem is it's the FCC in this country and it's somebody else's agency.
So the ITU.
But sure. What you need is they don't all have the same criteria, and the person who authorizes the launch, who's responsible for the objects in space, is the sovereign nation. And so it all depends on everybody using the same criteria or not, and then companies really adhering to that. Typically, and the problem when you think about it is space. I think, it's just this thing. Again, I have satellite jealousy here. Ours is like a.
You want to hold it?
But I don't get to keep it, right?
You can't hold his, though.
You can have that one.
Mine's a big fridge with arms, okay? But these things are moving so fast, and so if you think about it, it's just taking up that swath of orbit around, and so it gets more populated than you'd think.
Maybe I naively think LEO will mimic after GEO, and I understand GEO, you're above your country, and therefore that's your space, and that's what you get to regulate.
But if you just have one accident, space debris of less than 2 centimeters, okay, traveling fast will knock you out, and then you spoil this for everybody. That's just my fear, right? That something will happen, and then all of a sudden, because these things that you think that will never happen, they always end up happening. That's my fear.
Well, so speaking of spoiling things for everybody, I'll just put an end to this. I actually want to talk specifically about a problem related to these larger constellations that may or may not be a problem, but is very sort of public right now. Are people going to see these in the sky? Like when those Starlink satellites went up, everybody was like, what the hell? You putting these things up? Like, I can see them from my backyard. We don't want that. Are we just going to have a bunch of extra dots in the sky? And how do we, and if that's just ridiculous, how do we make people understand that that's not how it's going to be, and that if, as you say, orbit won't get crowded in a meaningful way, how do we explain that to consumers, voters, people who are in positions of power who may have an influence over this or an interest in this?
Well, you haven't heard anybody complain about our satellites because we're higher up, and so that we're protected from that. I don't know about the visibility issue and what they're doing to mitigate that, but obviously that is an issue.
You can't see our satellites either.
Well, they're very
small.
tiny. I'm asked.
I wish we could see them.
When Rocket Lab launched our first rocket with payloads, so we had 4 satellites, 2 Spire Lemur and 2 Planet Lab Doves. It's the names we call our satellites. We also launched with it a humanity star, which is basically a big disco ball that we put into the sky. And the mission and the point was to provide the Earth with the overview effect. It's a psychological experience as people and astronauts go into space and look back down to the ground. You see the Earth as one. You don't see borders. And you have this experience of unity. Well, we got a lot of crap for that, graffitiing the skies. Maybe this is deflecting your question, but what happens when the eVTOL, the electric vertical takeoff and landing, or the flying cars are taking us from San Francisco to San Jose on the regular, and not only are they loud, but they're polluting our airspace. Ultimately, I do think the technology developed in the eVTOL in the space, or the technology needed to get to and sustain life on another planet, will ultimately help back here. So if that'll convince voters or other people of the importance of this, and if there's a little more shooting stars or lights across the horizon, it's worth it.
A few more shooting stars. So on a more practical note, I want to ask you guys, how do you identify a business model with actual customers? Because I'm not sure that there are always customers for what you put up there. You know, you can kind of, Planet has put a bunch of things up there and they're imaging the world, and it's like, that's great, but they had to identify actual customers who will pay and make this all pay for itself eventually. So how do you identify customers, and how do you identify businesses that you can actually access with your hardware?
Well, Sarah has a long list of customers that have put orders in for her ground-based sensors to communicate, so I think that's a great way to do that.
Yeah, I mean, I think our customer base is very exciting because it's people that are currently using satellite communications. They're using Orbcomm, they're using Iridium, the Iridium satellite phones, and other types of satellite connectivity. But we're able to offer services at 1/20th the price. So that's super attractive to people that are already using satellite, and that's a $100 billion opportunity. That's massive. 100 million. And then what's also exciting is unlocking people that couldn't afford the satellite connectivity solutions before. So people that would love to connect their cows or their trucks or their beehives or their electricity meters or their agriculture sensor, but cannot afford $40 per device a month. That's completely outside the realm of feasible. But with Swarm being only a few dollars per device per month to send up a few packets a day or a few packets an hour, it's suddenly a lot more attractive. And I'm actually a lot more excited about all those new use cases that we're unlocking than the old ones. But Swarm is able to offer services to both types of customers. And we have over 200 customers that have signed up for early access. We've identified our first 10 customers, and we really haven't even started a big outbound campaign. We're just about starting that. So I am not worried about having enough customers. In fact, we will likely oversell our network quite easily with all the customers that are very interested in satellite connectivity solutions. And there's, you hear about tracking whales and kids and scooters, and it seems like every day there's a new exciting application where people want connectivity and can do really powerful things, monitoring air and water quality in Africa to save lives, enabling messaging when you're out hiking or backpacking, and there's more and more that keep coming up. So I'm not worried about that, actually. I think if anything, we're going to have to figure out how to kind of, have enough capacity to support all of those users.
So if I may ask though, was the business proposition this fully formed when you started out a few years ago, or did it have to evolve over time as you realized what your spectrum was capable of handling, what your satellites were capable of providing? How did that have to evolve over the years you've been evolving?
Yeah, so anyone that pitches for seed or Series A does not have their business figured out fully, and if they tell you they do, that's a joke. We certainly had ideas, and we thought maritime and agriculture would be really big use cases, and they are, but there are also several other verticals that are very interested in Swarm. And as you talk to customers and you really understand their pain points, that's when you are able to really identify where you bring the biggest ROI, what price points are attractive to certain groups. And that's an ongoing, continual process, and I'm sure it will continue to be throughout the lifetime of Swarm.
Adrian, have you identified your customers?
Yeah, I mean, everybody who wants broadband and who gets frustrated when they're on a ship or on a plane or they're in the middle of nowhere and they can't use it, or people that live in Africa and getting 1 megabit per second is a definition of broadband. I mean, when AT&T and Verizon deployed UVerse and Fios, 12 years ago, the smart people on the street were saying, wow, they're sinking all these billions of dollars into laying fiber, and they're crazy. But if you fast forward, 10 to 12 years later, everybody's addicted to broadband, and everybody wants it, and the countries and the populations that don't have it, particularly schools, are at a huge disadvantage. And so our business plan is all those people that currently use satellite and all those people that want broadband. You never hear of somebody saying, oh, I have broadband, but I've decided to go back to narrowband because I like that more. That just ain't happening.
So, but you kind of, I feel like OneWeb has sort of shifted from B2C towards B2B over the last, pretty recently, or has that always been the plan?
Well, so I've been on the job for like a year and a month. And so I was brought in because it was going from being a technology project to, okay, now, build it out, commercialize it. And the long-term mission of the company is to play its part in connecting people everywhere. But you can't attract capital if you're not going to give them a return, and you got to build a business. And so we're very focused on being B2B. We don't want to be, B2C. And that might evolve over time, but we think that we're working with a long list of people that want to distribute our product and that are very attracted to the global coverage. And then we layer on more capacity, and the capacity gets cheaper. The same like any mobile network. Coverage is incredibly expensive, okay? And then you're going to have hotspots, and the additional capacity is always less expensive. And on top of that, you've got the improvements in satellite capacity. And that just makes that even more. People talk about how many satellites we have, or Amazon's going to have, or SpaceX has, but satellites are not a unit of measure. It's like talking about a base station. I mean, a base station from 20 years ago, which was the first time I put one up, has nothing to do with a base station today. And so it's all a mix of what altitude you are, what your coverage is, how powerful they are. It's not a unit of measure.
So let me ask you guys, as you're going to be providing connectivity, are you going to be the broadband providers, your companies, or are you going to resell to local people, to local companies, or is it going to be, am I going to connect to, my phone connects to OneWeb, or my computer does, or whatever?
So we're not offering broadband. We're focusing on
the IoT
and lower bandwidth solutions. So we're trying to sell direct to as many people as possible. So we actually sell a modem, which would get integrated into an asset tracker or an agriculture sensor. We also have a standalone device that kind of plugs in, like through USB-C or Bluetooth, that you could carry with you, and it could essentially be a Wi-Fi hotspot. However, there is certainly a conversation of partners, and there's a lot of telcos that are very interested in expanding their coverage and partnering potentially with us. So that's something that we continue to explore and figure out what makes the most sense for Swarm. But we'd like to avoid selling through VARs, as many satellite solutions do today, which is extremely painful for most people that are trying to buy satellite. And so far, we've made a lot of good progress with those direct conversations, even with enterprise, but also the SMBs.
Mm-hmm. Adrian, we don't have much time left, but are you going to be the internet provider? Are you going to be the broadband provider?
We'll be the network behind. I mean, it's just too much neural damage to figure out what we're supposed to do in 180 countries. And we're going to focus on what is our core competence, which is running our network and our satellites and our ground station and protecting our spectrum.
And Tess, I guess I should probably just ask just to make sure, are you planning on launching a broadband connection?
I have so much admiration and respect for Sarah and Adrian. Nope.
All right, well then that's our time. Thank you very much for your questions. Thank you very much for your answers. And enjoy the rest of the conference.
Thanks,
Thank you very
Evan.
much, Sam.